Today we will study a scattering cross. So, scattering shape axis will be x1, x2, x3, y1, y2, y3 and z1, z2 and z3. Okay, these are the axes and they are parallel. They are parallel. Okay, so a target T transmitting antenna, a radar receivers are situated at a system x1, y1, z1 and x2, y2, z2, x3, y3, z3 respectively. Okay, so the transmitting signal from the transmitting antenna at a moving distance of r1 to t, in which it is scattered by target. Okay, scattered by target. What is showing that in scattering cross section there is scattering shape we are taking at axis x1, y1, x1, x2, x3, y1, y2, y3 and z1, z2, z3. They are parallel and there is a target in which there is transmitting antenna and receiving antenna situated between these systems. Okay, so the transmitting signal from the transmitting antenna moves at a distance of r1 to t in which is scattered by a target to all direction. Okay, so the signal moving at distance r to obtain the receiving antenna. So the signal which moves a distance r2 at receiving antenna at receiver. So the wave will be at incident is E is equals to, there is incident wave, so we denoted by subscript I. I is equals to E theta 1 A theta 1 plus E phi 1 A phi 1. Okay, where E theta 1 for the complex in amplitude of incident wave, E phi 1 for the amplitude of incident field in the direction of phi 1 and it is direction of theta 1, and A theta 1 A phi 1 are the unit vectors. So the power will be at electric field EI is that of the plane wave obtained by the Poynting vector magnitude of R1 is equals to EI magnitude the whole square to intrinsic, where it is represent a intrinsic medium. Okay, on scattering some of the scattered power moves a distance r2 to the receiving antenna. So in the spherical coordinate system, we can represent the scattered wave as E2s is equals to E theta 2 A theta 2 plus E phi 2 A phi 2. These are the unit vectors and these are the complex amplitude of the electric field component in the direction of theta 2 and phi 2. Okay, and these are the unit vectors. For the R2 distance, the scattered wave as E2 for the scattered wave into 2 into intrinsic impedance. So the radar cross section will be sigma s is equals to sigma s theta 2 and phi 2 is equals to limit r2 tends to infinity, because we are talking about the scattered wave. So 4 pi r2 square power per unit area in total scattered upon power per unit area in incident wave. Okay, so limit r2 tends to infinity 4 pi r2 square e2s upon ei square. Okay, so this is a